Hey, so last week I was tasked with creating a Laravel app and making a deployment one to many. Now, what does one to many mean? That simply means that we're taking a single Laravel app, building a Docker image of it, and we need to deploy this out to our own cloud, our staging servers on, depending on which deployment type that we're doing, and then also the ability for customers to run the app within their own infrastructure using Docker Compose. Now, a few important notes. This entire infrastructure is using Docker Compose and Docker Swarm. In this case, this application does not need 7 nines of uptime or anything like that. So Kubernetes is an option, but we chose to go with the far less complicated Docker Swarm, which still gives us our zero downtime deployments. Now, to go through this chart a little bit more in detail, we have our Laravel app starts with our source code. A GitLab runner picks it up. It builds a Docker image depending on the branch. So if it's a branch deployment, we'll do certain tests on it and everything. If it's committed to main, it will go straight to our staging server. And then if we actually do a tagged release, that's what we call an actual production release. If that's the case, well, actually both of these, they both go into a separate repository. So I have two pieces of code here. You can see I have my Laravel code here on the left, and then I have my Ansible code here on the right. And that's going to run a deployment playbook with Ansible. Depending on if it's staging, it will just grab my app.latest. And then if it's a tagged release, depending on what I set in the actual GitLab release itself with the tag, that's what our latest release will be. We build a Docker Compose file and it will go to our production server or staging server, depending on which route. And then our customers will be able to pull, the version 1.1 of our new deployment. Now, there's some very important concepts on this. We heavily utilize the Docker Compose override structure. So what does that mean? Usually a lot of people see just a Docker Compose.yaml, but ours has multiple. So we have Docker Compose YAML, which is our base file, and then we have a Docker Compose dev, and we use that specifically for development. So we set the base file here, and then the dev file is going to append to that. When we get into CI, we may want to just spin up a database just to run some test migrations, do all that, actually execute our tests, and then just kill the container and destroy all the data. That's great. And then in production, we may have some things that are running, differently compared to something like development. You'll see that here shortly. Now, looking at some of these files, just to kind of reiterate, here's the base file of like we have traffic, we have MariaDB, and then we have a PHP container, and then we get into Horizon, which is also going to be from the same source. Now, notice how this has a context of dot, which means in this current working directory of this file, just build the target at base. And that means that we have this Docker file in here that just says, hey, just pull, this is actually our open source image. Just pull that image as base and just run it. And you can see in something like development, if I look here, if I pull up this, we're just going to mount the volume essentially, and that's just going to expose our source code. Now, when it gets into something where along the lines of doing the actual production side of things, obviously we don't want to do that. We want all of our source code to be inside of the image itself. So that's where we have the other file is actually generated on the Ansible side. So you can see that I have Docker Compose, Docker Compose dev, Docker Compose CI, but we need to generate the Docker Compose production. Now, Ansible is a little bit of a different beast. If you're not familiar, if you're not a server person or anything like that, it may be a little complicated to understand some of the concepts. But what's really nice about this is I can break all of my hosts down into different environments. And so I can say, like, I want to group them by staging, by production, by stakeholders. I can do whatever I'd like with that. And then I can have different files inside of the host itself so that they're very unique. And what we're going to do is when we actually pass a file, let me pull this up. We're actually going to, because this is very important in a Laravel application, when you have the env file, if we package that into the Laravel image, that's going to be the same env file across every single environment. That would be across both of our production servers and our self-hosted, we do not want to do that. The way that we're doing this is we have mainly a very minimal like system env is what we call, where things are very generic and always going to be the same. But then there's the actual user things. That might be things like the database host, the port, the name, password, all that other stuff. And that's where we get into the actual templating of things. That's the benefit of Ansible is we have Jinja templating. So I'm able to take something like this and say, this is the actual Laravel env here, break this all apart and set it unique on a per host basis in an encrypted file. And then we actually have in our Docker Compose prod here, if I pull this up, here's the config. So you can see there's some Jinja code in here. It's going to do some special naming things. And that's where we're able to create these configurations on the fly and dynamically on a per host basis, or I can customize the variables at a group level, which is cool as well. Now, when this file is built, we then have Ansible go through and actually do the deployment. Let me pull that up. So we're going to do tasks main. And so we ensure the app is called Nucleo. We log into the registry. We ensure the config files are present. We load those config files up into the Docker Swarm cluster, basically. Most of these are single host. We make sure that the compose file is up to date, and then we automatically deploy this with Docker Swarm. And so then we have the services get executed, and then we clear the Cloudflare cache automatically. And so this is what you can see. This is an example server here of what it looks like on a production machine. So when the services are brought up, so in this example, we have version 2.18.1. Let's say that we wanted to deploy version 2.18.2. This would bring up the services in 2.18.2, make sure that they're okay and healthy, and then it will change the service through traffic. Because remember, everything in traffic, that's handling our actual proxy, or it's our reverse proxy. It cuts it over to version 2.18.2, and then it brings everything down on 2.18.1, and then we have a zero downtime deployment through that service. So I just wanted to share a few things. That's basically the end of my kind of discovery of what I learned last week. This is the first time I've done something like this. So if this is something of value, feel free to hit me up on Twitter at JD Rogers. I'm also available on GitHub. But if you have any questions or have any further thoughts, I'd love to hear them. Thanks.